All right, welcome to lesson 9.1.2. Today we're going to be doing more proportional equations. In fact, we're going to be talking about several ways of solving proportions. So let's get right to it here. All right, question number 15 here. Robert's new hybrid car goes 420 miles on 12 gallons of gas. So what we need to do is figure out, well, what would it go on these different amounts of gas? Now, without setting this up on a proportion and solving it that way, let's just think about this and answer the questions here. 6 is what of 12? You should have been thinking half. So what would be half of 420? Hopefully you said 210. Okay? Well, if 210 is half of 420, let's think about 3, for example. 3 would be half of 6. So half of 210 would be 105. And obviously, if we had no gas in the car, how many miles could you go? 0 miles. So there's one way of proportional reasoning out something, is looking at kind of what you know about different things and being able to solve that. But let's say they ask you a question about if 420 miles is to 12 gallons, then how much would 8 gallons be? Well, this might be one where, setting it up into a proportion, 420 miles is to 12 gallons, as X number of miles is to 8 gallons, and then solving that proportionally. Now, if you can think about it, 8 is 2/3 of 12, and if you can think about what is 2/3 of 420, you could solve it that way. Otherwise, you just need to cross multiply the 8 times 420 and get that. Or you could take and divide 420 by 3 halves to get your same answer, or multiply by 2/3. All right, moving onward and upward. Question number 16. Now we're going to be using an example, and we're going to be talking about scale factor, okay? All of these are different ways you've learned throughout the years. We're just kind of putting them all together here. Lexi claims that she can text 14 messages in 22 minutes. Her teammates Kenny and Esther are trying to predict how long it would take Lexi to text, or how many words she could text in 55 minutes. So we kind of set up a little triangle here for you. 22 texts in 14 minutes. How many minutes would it take her? 55 minutes would allow her to send how many messages? So to get from here to here, you'll notice that this is 55 over 22 times bigger. So if you think about that, 55 over 22, pretend I have a fraction bar right there, that would simplify to 5 over 2 because you could divide both by 11. So our scale factor here is that this is 5 halves bigger than this right here. So in order to solve for x here, we simply take 14, we multiply it by 5 halves to get our answer. How do you multiply by 5 halves? Well, here we go. Obviously, you could do your multiplying fractions as no problem, but another way is just take the 14 times the 5. 14 times 5 is 70. 70 divided by 2, half of 70 would be 35. So she could text 35 messages in the 55 minutes. Another way of thinking about this is if she can do 22 minutes for 14 messages and 55 minutes for X number of messages, you just have to multiply the top by the same thing you multiply the bottom by. We kind of call that the big one theory. So if you take 22 times 5 for 110, divide that in half, you get 55. Same thing here, 14 times 5 is 70, divided by 2 is 35. You can get to your thing. Big one theory is that whatever you multiply the bottom by, you got to multiply the top by, or vice versa. Because 5 halves divided by 5 halves is 1. Just like 4 divided by 4 would be 1. Anything divided by itself equals 1. So there's your big one theory. Moving onward. Number 17, this is one of my favorite problems. The yogurt shop. Okay, so the yogurt shop, it's called Jelly Bean charges $32 for 5 pounds of dessert. The problem is 5 pounds of dessert is a lot of yogurt. Now you can put on as many toppings as you want. I mean, you can add raspberries, you can add Skittles or M&Ms or strawberries, raspberries, blueberries, you name it, whatever you want to put. Heck, put croutons on there for all I care. Whatever you put on there is your choice. All Jelly Bean does is charge by the pound, okay? And so their base price is $32 for 5 pounds. So if you think about it, 2.5 pounds of yogurt is going to cost, 2.5 is half of 5, 2.5 would be half of 32 or $16. You can just kind of proportionally think about that. Now, what would a graph of that look like? So if we graph this, it might make sense that 0 pounds of yogurt is going to cost 0 money. Okay, 1 pound of yogurt is going to be 2, 4, 6, somewhere close to $7, but not quite $7. Here's where our 2.5 right in the middle here would, if you travel that one up, 2.5 is going to be, oh, I see, it's right here in the middle, is going to be $16 right there. So here is the graph of that. However, if you go to most restaurants, they don't charge it. They're not going to charge you. So, for example, if you got a 1/4 pound, they're not going to charge you proportionally right away. Actually, what a lot of them do is, if you see on number C here, Jelly Bean decided to start charging $2 for each cup. Now, a cup doesn't cost them $2, but it gives them a starting place for charging, and then they'll charge you a proportional amount from that point on. Okay, so $2 for the cup, and then you still pay $32 for 5 pounds of yogurt. But how does this adjust the graph of this? So if we have this graph, and here's the original line for the $32 without the cup charge, but now that they decide to add a cup charge, you will notice that the blue line graphs the new spot, where we have the initial cost of $2 for the cup, and then it goes up. So all along, you're paying a slightly higher price for, for 1 cup or for 1 pound. Instead of paying here close to $6, you're paying close to $8, which makes sense. It's about $2 more. When you get to 2 pounds, you're probably paying about $1.25 more. When you get to 3 pounds, you're probably paying, 75 cents more. When you get to 4 pounds, you're paying only about $0.25 more. When you get to 5 pounds, the two of them are equal. You might notice too, though, this is good if you want to throw a huge party and you buy a lot of yogurt. Now the cup charge way of doing it actually saves you money. But here's one thing to think about. Whenever your line does not cross at the origin or the point 0, you are no longer proportional. So while the maroon line here is proportional, okay, the amount of yogurt is based on the number of pounds, the blue line is not proportional. The amount that you're going to be charged is not solely dependent upon how much yogurt you're going to buy. It's also dependent upon that $2 cup charge. So the blue line here is no longer proportional. So whenever you're thinking of a graph, the only way you can ever be proportional is if that graph crosses through the origin. In other words of thinking about that is if you think about the gas problem. If you have no gas, you go no miles. That's a proportional relationship. The yogurt cup one originally, where they just charged you based on the amount of yogurt. 0 yogurt is $0. Okay, but as soon as they introduce that cup charge, then there is a charge. For another example of some that is not proportional, if you go into a taxi cab driver, they're going to charge you a flat fee just for stepping foot into the taxi. And then after that, they charge you a per mile or per time or whatever type thing for charging that. So a taxi cab driver would not be a proportional relationship. So let's go back and see if I've completed everything I want to talk about here. It looks like I have. So you guys have a great day, and we will see you tomorrow.